talk a little bit about the ergonomics and introduction. So ergonomics is the study of designing devices and equipment that fit human body and its cognitive abilities. Ergonomic simulation provides tools to analyze virtual products or manual tasks within a virtual environment. Ergonomic tools such as Jack software creates a virtual representation of the human mimic postures, mechanical loads, and performance of a human in a simulated environment to develop and improve the design of products and work environment. Over on the left, you can see a picture. That picture represents the optimal workload for both a man or a woman of average size, weight, and strengths and abilities. Jack software is a modeling and simulation software solution that helps improve the ergonomics of workers and helps refine workplace tasks. Jack enables you to build a virtual environment, create virtual human, defines the human size and shape, positions the human in a virtual environment, assign human tasks, analyze human performances. The information obtained from Jack can help design safer, more ergonomically safe products, workplaces, and processes faster and for less cost. We'll talk a little bit about the Task Analysis Toolkit. Task Analysis Toolkit will evaluate the arm strength, fatigue analysis, force solver, a lower back analysis, manual handling limits, metabolic energy expenditure, the NIOSH, which we'll talk more of, the Ovako workplace posture, predetermined time standards, rapid upper limb assessment, and static strength prediction. If you look at the way this is written up here and you see anything that's highlighted that is in bold text, those would be the areas that we're going to cover today. If we tried to cover all the areas today, it would be a very, very long day for us to cover it all. So we're going to cover the most used products within the toolkit. Looking off to the right, you'll see some examples of how the analyses are done and the different ratings that they get, which we'll also talk about. So we'll start with the lower back analysis. The low back compression analysis tool helps us evaluate the L4, L5 spinal forces acting on the lower back under any posture and loading conditions. With this tool, we can evaluate tasks in real time to identify compressive forces, moments, and estimated muscle tensions throughout your simulation. 3,400 newtons is the NIOSH back compression action limit and represents a load where there is an increased risk of lower back injury for some workers. 6,400 newtons is the NIOSH back compression maximum limit, representing a load where there is an increased risk of lower back injury for most workers. The low back compression analysis tool helps us evaluate the L4, L5 spinal forces acting on the lower back. So off to the right, you'll see some of the pictures showing you the different areas of the L4 and the L5 spinal areas. So what is the L4 and the L5, and why do we do this? The L4 and the L5 is a spinal ligament position in the lower end of the spine that play an important role in the important torso movement in the multiple direction. These segments and discs bear the most weight and therefore the most prone to degradation and injury. Jack software lower back analysis. Shown above are some of the sample results for the lower back analysis from Jack. You see how everything is green at this point and within range. Talk about a Ovako working posture analysis, also known as OWAS. Ovako Working Posture Assessment System is a postural assessment method that is conducted by encoded posture. OWAS identifies the most common work postures for the back. 4 postures, arms is 3 postures, and legs 7 postures. And the weight of the load handled is 3 different categories. Off to the right, you'll see samples of the different postures in arms and legs that we just spoke of. So OWAS has the following rating scale of 1 to 4 for postural load on musculoskeletal system, the MS. 1 is the first rating. There's no need for corrective measures at all. 2, corrective measures are encouraged. Not really necessary, but they're encouraged, so you really want to look at it. 3, corrective measures must be taken as soon as possible. So this really says that you got to get out there and you got to get this done, get some engineering design work redone on the station. Injury is more than likely going to happen. And 4 is a warning. Corrective actions are required immediately. When you receive a 4, working posture analysis, you need to stop work. And I know that sounds terrible and it sounds expensive, but we all want to go home at night. So the Ovako Jack software sample results. As we just talked about, there are the 4 areas. And as the videos will run, you'll notice these areas turn green, yellow, orange, and red to represent the different numbers, 1, 2, 3, and 4, respectively. So the green is a scale 1, scale 2 for the yellow, scale 3 for the orange, scale 4, of course, for the red. And we'll look at the RULA, the Rapid Upper Limb Assessment. RULA was developed to evaluate the exposure of individual workers to ergonomic risk factors associated with upper extremity musculoskeletal disorders. RULA considers biomechanical and postural load requirements of job tasks on the neck, trunk, upper extremities. RULA rating scales run from 1 to 7, which are a little different than we've seen before, on the 1 to 4. Looking at the diagram below, you can see the different ratings and different scores and how they move up. So this sheet shows a RULA sheet when assessed manually. So if I did this by hand rather than using the Jack software, this is the sheet that we would have to work out. Every task here must be evaluated manually sequentially from table A, table B, table C to get a final score. Jack simplifies this for the user and calculates all those scores based on the selected task posture. Rapid Upper Limb Assessment tool helps us to evaluate suspicious activities that may need further ergonomic investigation. RULA evaluates the upper extremities, can further explain where the ergonomic hazard on a worker is, mostly concentrated. Looking above, we see a RULA score of 4, so the risk level is really, it's low. However, you probably want to look at it. You may need a change. Next picture, you're going to see a RULA score of 6. The risk level is medium. So you need to get further investigation immediately, very soon. And then once we hit the 7, once again, that's emergency and it's high. Stop what you're doing, investigate, and change it immediately. The nice part about using the Jack software is you can do all this before you ever put anything on the floor. So you never really have to change a design if you run Jack software on the suggested design. So once again, we're looking at these different scores where a 1 to 2 is a negligible risk, no action required. 3 to 4, low risk, change may be needed. 5 to 6 is medium risk. Further investigation, you probably want to change it soon. And then over 6 is very high risk. Stop what you're doing and change it now. Such assessments by Jack help the user to find the problematic areas. So we see over on the first side, the problem that we're having with this yellow is someplace in the upper arm. And the second slide, once again, is showing upper arm problems with a rating of 5. We also see that the body group B posture rating is also high. At the neck is a 5. However, the trunk seems to be okay at a 3. And then we'll go to the static strength prediction. Static strength prediction can be used to aid the evaluation of the physical demands of the prescribed job, therefore helping design or redesign a proposed workplaces for a fraction of the cost that would entail the trial in the air. Static strength prediction in Jack helps predict the static strength requirements for the tasks such as lifts, presses, pushes, and pulls. Output includes a percentage of men and women who have the strength to perform the described job. Now we're going to do a quick software simulation. We're going to show you an actual video of a simulation that we've created. See the operator moving. You can see the different analysis running within it. We can stop the video at any time so that we can see where we're changing red, where we're changing yellow, where we're staying green. As you can see, as the operator moves to put pistons into the block, he turns highly yellow. There was a problem there. We'll look at it one more time. Note that all the postures and all the reaching and all the muscle strength are being evaluated at this time. So the Jack software lower back analysis, SSP, and Ovako, Different jack analysis run live during the simulation, where we can easily identify the working postures that may represent ergonomic hazards to the workers. Further, per-task investigation is conducted to reassure that the task does indeed represent an ergonomic issue. So we're looking at the same still photos of the task that we just looked at. We can see where we're yellow at. We can also see where we started to turn yellow, where we began to have identify issues. We'll look at these certain issues. We'll put corrective actions into place, or at least recommended corrective actions into place. And see, then we'll also resimulate those and see how they come out. We run a JAC software NIOSH analysis. NIOSH lifting equation is a tool to assess the manual material handling risks for tasks involving lifting and lowering weights. NIOSH helps predict lifting-related injuries for an 8-hour day, whereas other analyses are more task-specific. Two key outputs of the NIOSH lifting equation is the recommended weight limit. That's the maximum weight which all nearly healthy employees can lift without increasing risk to the musculoskeletal disorders to their lower back. Lifting index, it provides the relative estimate level of physical stress to the musculoskeletal risk associated with the lifting task. So the process looks kind of like this. We take a look at the ergonomics. Is it a load, a heavy cyclic load? If it's yes, we begin to do a NIOSH analysis, and then we'll move into the other analysis. If it's a no, we'll probably go by the NIOSH. We'll go straight to the JAC analysis for the Ovako, the lower back, and the RULA. So you ask, well, then why do the NIOSH? Well, NIOSH helps to determine the lifting index. Lifting index equals the load, the weight of the load in pounds or kilograms, divided by the recommended weight limit. The load index can be used to estimate the relative magnitude of the physical stress for a task or a job. The greater the lifting index, the smaller the fraction of workers capable of safely sustaining the level of activity. Thus, two or more job designs can be compared. How does it work? It's a recommended weight limit. Recommended weight limit equals LC times VM times DM times AM times FM times CM. All that has a lot of meaning that I could go into, but we're not really not going to go into that at the moment. I just want to kind of cover it. The equation is based on a model that provides the unit value for 6 tasks, variables, and 1 constant. By changing these variables, the task could be made more suitable for a higher percentile of the population. So if we look below, you can see what all the acronyms meant. The summary of the recommendations for the task based on the above 6 variables. NIOSH analysis. Use JAC software to simulate the postures for lifting, lowering tasks using a human in a virtual environment. Example, the operator lifting packages from a table and placing them on the table to his left. 5 hours of lifting in an 8-hour shift. 1,000 packages are lifted in a day. Load of the packages vary. The average load equals about 5 kilograms, and the maximum load is 10 kilograms. Shows the original posture, the destination posture. See here in the video. And that's the task. 1,000 times a day. JAC TAP NIOSH analysis. This is the output of the task analysis toolkit. What we're going to look at, you can see that different weight limits, different loads, and how they're rated. Task is okay. Task is borderline. Task might have an increased risk. Likely increased risk. Task needs to be redesigned or automation is put into place. The particular lifted task seems to have an increased risk to the worker. The recommended weight limit for such a task is 4.3 kilograms. So we go back and we look at that package and see how we can lower that. So when PMC approaches a project such as this, we're going to look at everything that we have to look at and gather the information. We gather 3D models of the environment. If they're not available, we'll create them. We create 3D models of the parts and the tools. Once again, if they're not available, we create them. We gather the anthropometric data, the measurements of the work zones, and then we also do video recordings of every video, of every task. What we build, we create a virtual environment utilizing the 3D models. We create human models, creating the anthropometric data. We create task simulations, the hand movements, upper arm movements, lower arm, grasp actions, the adjusted torso. axial rotations, and later the lateral rotation. Then we analyze everything. We analyze the arm strength, fatigue analysis, force solver, lower back analysis, manual handling limits, metabolic energy expenditure, the NIOSH, the Ovako working posture analysis, predetermined time standards, rapid upper limb assessment, the static strength. So just a quick mention, we've mentioned predetermined time standards. Part of what we also do when we create these different tools and utilize in our video recordings is we also do a MODAPS analysis of everything. So we also come out with actual times. So we deliver the outcome, assess current working conditions, provide an ergonomic assessment for each task associated with the process, identify awkward posture and postures of discomfort, categorize and quantify the risk level. We suggest changes to eliminate the ergonomic risk associated with the process.